I do want to touch on all of the little different things that can happen. So for example, when I have a problem like this, cosine squared equals 1, I can still work through this the same way. I'll replace cosine with x, and I would write this as x squared equals 1. How do I solve a squared when it just equals a number? Take the square root. So I'll square root both sides, but I have to make sure that I don't forget the plus and minus part. I just want to remind you of that, because on your test, guaranteed, there is a problem like this. And about half of you are going to forget the negative. Okay, so keep that in mind. This is x equals plus or minus 1. So I want to figure out when the cosine is positive 1 and when the cosine is negative 1. So not a very complicated problem, but this is something that people forget a lot. So when is the cosine positive 1? What did we say? 0 pi, great. And then when is the cosine negative 1? At pi, okay? Because I'm solving for all solutions, how does that change my answer? Yep, because I want to get back to there, plus 2 pi k, plus 2 pi k, where k is an integer. I could actually write this answer a different way. We talked about this a little bit yesterday. Because 0 pi and pi are pi apart, I could, this would be one possible solution, I could write this as theta equals 0 pi plus pi k, where k is an integer, and that would cover the ground. Now the reason that I bring that up is because, especially if you're doing multiple choice, they could show you either way, and most likely they'll show you this way. So even if you get this as your final answer, you need to be able to translate it to this other form if possible, okay? All right, so that's kind of one of a couple of the little funky things that can cause a problem. Similar in problem number 2. I'm going to replace sine theta with y. So I get 1 plus 2y squared equals 2. This is another situation where I don't have the y term. I have a y squared and I have a no variable term. So I can set it up similar to 1, where I get the squared on one side and the non-squared on the other side. So this is 2y squared equals 1. Is everybody with me so far? Any questions on that? I cannot take the square root until I get the y alone, so I'll divide by 2, and y squared equals 1/2. When I take the square root of both sides, I will end up with y equal to plus or minus the square root of 1/2. Sometimes that freaks us out when we see stuff like that. But we've done these before, similar problems. I just have to break that apart. Y is equal to plus or minus the square root of 1 over the square root of 2. So y is equal to plus or minus 1 over the square root of 2. Now, is that the same thing as 1/2? No, it's not. And I can't just say close enough. And right now, this doesn't look like something we know. But remember, rationalize the denominator, and then you should start to see something that looks a little nicer. So when I'm all done with this, when I've gotten y by itself, I've done all the cleanup, what I really am trying to find out is, when is the sine theta equal to the square root of 2 over 2, and when is the sine theta, I need to move that over, sine theta equal to negative square root of 2 over 2, and you all know that's when? Pi over 4 family. Because it lists all of these, positive and negative, I am going to write that theta is pi over 4, and theta is 3 pi over 4, and theta is 5 pi over 4, and theta is also 7 pi over 4. How do I finish this up? Plus 2 pi k. What the heck is k? K is an integer. Can I rewrite this one differently? Could I use just plus pi k on this one? I can, because I'm all the way around the circle. So I could get, from pi over 4, I could get to 5 pi over 4 by adding pi k. And from 3 pi over 4, I could get to 7 pi over 4 by adding pi k. So this answer, this is a totally acceptable answer, but this answer could also look like theta is pi over 4 plus pi k. Theta is 3 pi over 4 plus pi k. That'll get me into the first and the third, the second and the fourth, where k is an element of the integers. Now, I'm not showing this to you because I want you to get confused. I'm just showing this to you because, again, you have to think about moving around the circle, and if it can be written a little bit differently, it might. If you write it like this every time, you're fine, as far as I'm concerned. But just know that it could be adjusted. All right, yellow sheet's handy. Does everybody have their yellow sheet? Was anybody not able to find their yellow sheet? Let me see if I have some extras. Anybody else need one?
Yeah.
You're welcome. Okay, so in the next problem, I have cosecant and cotangent. I have two different trig functions. I have two different variables that I'm solving for. And up to now, what we have done is replaced one with x and replaced the other with y, but that's not the only option. And on occasion, when you try to replace one with x and the other with y, you're not even going to be able to get any further. You won't get yourself in a situation where you can solve, and that's where our trig identities come into play. I have an identity that connects cotangent and cosecant. In fact, it says that cotangent squared plus 1 is cosecant squared. I have a cotangent squared here. So if I solve for cotangent squared, I would have cotangent squared theta equals cosecant squared theta minus 1. I can replace this with cosecant squared theta minus 1. So if you replace with x and y and get nowhere, take out your yellow sheet and see if there's something that you can trade over with. How does this help me? Because now I have -3 equals 3 cosecant theta plus cosecant squared theta minus 1. Now that I'm down to one variable, I can call, I'll just call m today, cosecant. And so this is -3 equals 3m plus m squared minus 1. One variable, much easier to solve for. So just that little swap, connecting this to something that we know, is enough to make this solvable. So now I'll move this around. 0 equals m squared plus 3m plus 2. And 0 equals, go ahead and factor. Did anybody factor that already? Yep, Glenn? So when I solve this, m plus 2 equals 0, m plus 1 equals 0, m is -2, m is -1, but not m, instead cosecant. And so now I'm down to a very basic equation. Cosecant is associated with which trig function? Sine. So really we're looking here for when is the sine -1/2 and when is the sine -1, because the reciprocal of -1 is just -1. I always like to put it in terms of something that I know. So when is the sine -1/2? Pi over 6. And in what quadrants? Third and fourth. So we would do 7 pi over 6 and 11 pi over 6. Good. When is the sine -1? Three pi over 2 plus 2 pi k plus 2 pi k plus 2 pi k. K is an integer. I want you guys to try number 5. Give number 5 a try. It's very similar to problem number 3. See if you can find the change or the switch that you can do, and then work your way through and solve. I say we're good to do 2 more on this sheet, okay? But I want you guys to scan through all the rest of the problems that aren't done and pick any 2 that we'd like to do. I mean, I'll write down what the suggestions are. Which 2 should we do together? 10 and 6. Anybody else? You agree? 10 and 6? They look complicated? Anybody say anything else? We'll agree on 10 and 6 then? Sure. Okay, perfect. 10 and 6 they are. Let's start with 6. Are we ready? This is a lot like yesterday's. I do not have, search as I might for number 6, I do not have an identity. Well, I guess I kind of do. I don't have an identity that would allow me to wipe out one trig function totally. I could replace cotangent with 1 over tangent. But over here, it's still going to put tangent in the denominator, and that's going to cause a problem. There's no squareds that I can do. There's no way that I can wipe one out. So this would be a prime candidate. And usually when there is no squared in there, that's not always the rule, but when there's no squared in there, you're best off just replacing one of the trig functions with one variable and the other one with another. So this would be maybe x equals cotangent and y equals tangent. And it really doesn't matter what variables you use. Makes no difference whatsoever. So I have 3xy minus the square root of 3x minus 3y equals negative 3y. And now when I have two variables, what I like to do is get everything equal to 0. This would be 3xy minus the square root of 3x equals 0 when I solve. Factor out the x. Set your factors equal to 0. And solve. So x is 0, that was an easy one. And y is add the square root of 3, divide by 3. So when is that the square root of 3 over 3? Hopefully both of these look familiar. So I want to figure out when the cotangent is 0 and when the tangent is the square root of 3 over 3. When is the cotangent 0? Pi over 2. It's 0 when the cosine is 0. So the cosine is 0 up here and down here at 0, 1, and 0, negative 1. So theta is pi over 2, and theta is 3 pi over 2. When is the tangent the square root of 3 over 3? Pi over 6. Nice job. When is the tangent positive? First and third. So this is pi over 6 and 7 pi over 6. Is it negative? No, I'd add the square root of 3. My thing might look, that's my radical. Sorry. If my handwriting were at all legible, you'd see. That. There we go. A little better, right? Okay. Now remember, we finished this off with plus 2 pi k, plus 2 pi k, plus 2 pi k, plus 2 pi k. K is an element of the integers. Or, how else could I write it? Theta is pi over 2 plus pi k, and theta is again, k is an element of the integers, so I could accept this answer or this bigger answer. And that'll work for tangent all the time. Knowing your way around the unit circle is very helpful. 10 was the last one. 10 was the last one. And I'm glad you guys asked about 10. Because what happens when you have that angle in front of there? Or that, yeah. So I have to remember that what I add on the end here, instead of 2 pi, is going to be 2 pi over 3. Okay? Because this number in front of the angle will change how long it takes to repeat itself. Or instead of, yeah, exactly, yep. Or because this is tangent, and it only works because this is tangent, I can take the first answer and add pi over 3. If this were sine and cosine, it wouldn't be the same, cosecant, whatever. Okay, so this is 4 times the square root of 3 equals 4x. Get x alone, what do I do? Square root of 3 equals x, except for I'm not solving for x, I'm solving for the tangent of 3 theta. When does the tangent equal the square root of 3? Remember, it's sine over cosine, yep, pi over 3. So that's when you put the square root of 3 over 2 over 1/2. And this is the pi over 3. So this is pi over 3 family. When is the tangent positive? First and third. So this would be pi over 3 and 4 pi over 3. So my answer would be 3 theta equals pi over 3. And 3 theta equals 4 pi over 3. Remember that 3 messes with you in 2 different spots. It messes with you with what you add to get your all solutions. It also messes with you when you find your angle. I don't want 3 theta, I want theta. How do I solve? Great, so this is pi over 9. And theta is 4 pi over 9. So now here are my 2 options for my equations. It would be theta equals pi over 9 and theta equals 4 pi over 9 plus 2 pi over 3k plus 2 pi over 3k. K is an integer. Or theta equals pi over 9 plus pi over 3k, where k is an integer. Only works for tangent, only always works for tangent because of how tangent works. But you'd only need to write the first one and then work with pi instead of the 2 pi. So that is me done talking for the day.